Right. Okay, we've moved from a quadratic to off form, as I said, the graph with the 1 over x that you see in there. And now we're going to do a little bit of a tricky graph, which is an exponential curve. Now, how do you know what's an exponential curve? When you see something like this, y equals to 2 over x, 2 to the power x, or e to the power x. These are called exponential. What do we mean by the word exponential? Exponential, it means increasing at an exponential rate, remarkable rate. All right, you can see that when x, the power there is 2, to the power 2 is a 4. But when x becomes a 10, 2 to the power 10 becomes 1024, 1024. Do you see when x is 2 moving to 10, there's a jump from 2 to 10. The y jumps from a 4 to 1024. So you see the exponential growth, a very big slope, a huge slope, the speed of increase. So we're going to draw a graph something like that. Well, they ask you to draw the graph of this after completing the table below. And they've given you a scale. Please look at your graph papers and see how you can use this. 4 cm to represent 1 unit on the x-axis and 2 cm to represent 1 unit on the y-axis. So these are just guidelines on how you can do it. All right? Now, then you ask to solve graphically 2 to the power x at what value of x when 2 to the power x is equal to 5. And they also ask you to find on the same axis, they ask you to draw this line. It's a straight line. And then they ask you to find the coordinates when this curve and this line meets. All right, get the total picture of this sum. And the last part of the sum, they ask you, hey, find the slope. The slope is none other than finding the gradient. At a point, this is when x is 2, y is 4. Are you ready? I hope you've done it. And let's go through the solutions. Now, when x is a minus 1, all right, when x is minus 1, 2 to the power of minus 1, that's where you apply the laws of indices. 2 to the power of minus 1 is actually, like, write it, 2 to the power minus 1 is 1 upon 2. So that's a half, which is 0.5. 2 to the power of 0, laws of indices tells you anything to the power of 0 will be a 1, any number, right? And 2 to the power of half, we'll get that on your calculator soon. 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3, 2 times 2 times 2 is 8. Yes, use your calculator, get me the answer, 2 to the power of half. Right, 2 to the power of half. You get 1.414. We just need about there 1.4, that will be fine. Now use these points to draw the graph, and then from there we move on. The highest point of y is an 8 and the x is a 0.5. Look at the point again when x is negative. Minus 1 goes right up through 0 and to 3. X minus 1, 0, and it goes 1 to 3. And look at it, y is still positive, right? We know in the laws of indices, any number, even if 2, if it had been 2 to the power of a minus 100, it's still 1 over 2 to the power 100, right? The numbers are always positive. Just use that added information that you have on indices. Now, so it is 0.5, the y. It goes up to 0.7, and then it goes to 1, 1.4, 2, 2, and it goes to 4, and then you can see the jump from 4 to 8. You see the curve goes that way. Do you see that? That's an exponential curve. All right, now let's get it done. Let's see how your curve works along. Now it's all a positive reading for y, and so we draw the graph, part 1, and x is 0 here, and y goes up to 8. So I put here 2, 4, 6, 8. Well, you use your guide on what is given to you. Now, and here x is minus 1. So I like to put here maybe a half, a minus half, a minus 1. And then x is 0. Here will be a half, a 1 and a half, 1.5, and then a 2. It goes right up to 8. So I got to go up to 3. Look at that. All right, 1.5, 2, 2.5, and 3. All right, that's how it's going to be about there, the calibration. Now, from there, you look at a graph and said, hey, let's plot it. When x is minus 1, y is 0.5. This is a 1, a 0.5 is near there. When x is minus half, y is a 0.7, slightly below 1, so 0.7 there. When x is 0, y is 1, 1. When x is half, y is 1.4, is between 1 and 2, 1.4. When x is 1, y is a 2, 2. When x is 1.5, it's not given x because I needed the space 1, 2. When x is 2, y is 4. 4 is somewhere here. When x is 3, y is an 8. All right, so we've got this shape, steady hand, and we see it going up. If I had 4 here, x is going to be 16. You can see it going exponentially fast. But when x gets more and more negative, it's just coming towards the y-axis here. I mean, the y equals to 0, which is the x-axis. All right, as I told you, if x is a minus 100, 2 to the power minus 100 is 1 upon 2 to the power 100. Huge, isn't it? And 1 upon a very big number gets almost 0. So do take note of that. Now, the next part of it, they're saying, hey, what is the solution when 2 to the power of x is equal to 5? 2 to the power x is equal to 5. Look at 5. Y is 5. Y is 5. And read that solution. All right? So they said 2 to the power x is equal to 5. So what happens? X, graphically you can read. This is your y. Your y is 5. Your x is about 2.5. About there, slightly less than that. Now you can check it out on your calculator. Say 2 to the power of 2.5. What do you get? All right, just be working along with your calculator to see if you are there. 2 to the power of 2.5. Right, you got about 5.65. You look at that. Your calculator will tell you 2 to the power of 2.5 is 5.65. As I said to you, this is a graphical solution. Maybe 2.4 will be better. So look at that and try it again. Let's try it again. 2 to the power of 2.4. Enter, you get 5.27. So this is where your human eye and your calculator, you can work silently and you can make a little alteration. I'm playing. This is not cheating. I am being smart. I'm sure you're being smarter, right? And that's the way to work with the calculator and the human brain. As I said, if you don't use your brain, you get an FB. What does the FB stand for? I'm not being dirty. FB, a frozen brain. All right? So use as little as you can, but just use that calculator when necessary. So that's your answer for this when 2 to the power x equals to 5. Next, on the same axis, the x and y, you have to draw the line of y equals to minus 2x plus 3 and find out when the two graphs meet. Now this is a straight line. When x is 0, y is 3. Yes, so you can plot the point very easily. You only need about 2 points. When x is 0, y is 3. When y is 0, you bring y is 0, bring your 2x over, 2x is 3, so x will be 1.5. So that will be your 2 points, good enough to draw your straight line. So this name of this graph, your y is equal to minus 2x plus 3. Now you can see from here, the two graphs meet about there. Alright, here. They meet at this point, and this point here is slightly around there. Look at that. Alright, so write down the coordinates, the two graphs, write down the coordinates where the two graphs meet. Alright, so I'm going to write it here. When 2 to the power x is equal to minus 2x plus 3. At what point? When x is about 0.5. Alright, when x is 0.5. Or you can say 0.6. If you think it's nearly there, let's put it first 0.5 and later test it. And look at your y here. Your y is about 1.8, around there, about there. Now let's look again. We said x is 0.5. Let's do a test again. Use your calculator, my dear. 2. You're going to use the calculator in your graph to help you to see how far off you are. 2 to the power of 0.5. Press it and you get the answer 1.41. 1.4. And here, if you put in 0.5 at this part of the graph, minus 2 times 0.5 minus 2 times 0.5, which is a half, plus a 3, you get a 3, take away a 1, you get a 2. Alright, 3 take away 1, you get a 2. Whereas if you put a 0.5 here, you get 2 to the power 0.5 is 1.4. So I'm going to look at it. Let's see. Maybe if I put a 0.6, alright, because it's slightly off there. Alright, calibrate it. Oops. Alright, you get 2 to the power of 0.6. Alright, what's your answer? You get 1.51. And if you put 2, if you look at it here, minus 2 times 0.6 plus 3, you get a minus 1.2 plus 3, you get a 1.8. So both answers nearly match. Alright, so I would choose to take the answer 0.6. Alright, and anyway, if you look at it, it's a little off 0.5 too. So I'll put it as 0.6 and my y is about 1.8. That is the coordinate when the two graphs meet. Now what I'm trying to teach you, my dear, is that not all the time, alright, reading the graph, you need to be wise, be intelligent, use your calculator to help you in some ways, although they said graphical solutions, because we've got our human eye, human error in drawing to some points sometimes, alright, because we're drawing the graph. It need not be 100% accurate, but it's about there. So a graphical solution gives a solution which is just about there, alright? Now the next part of the sum, we look at it, find the slope. What is another word for slope? Gradient. That's what they're asking you to find. At the point 2, 4 on the curve. So when x is 2, y is 4, alright? What is the gradient at this point? All you need to do is draw a tangent. And you said, alright, that's your tangent. You need to find the slope at this point. How do you go about it? Well, you need 2 points, my dear. Well, here at 2, 4, take 2 points. As I said, it's good to have a point where the x is a whole number. X is 3, x is 3 here. Look at this line. Y is about 7, right? Take another point when x is 1. All right, x is 1, y is about 1.2, around this, slightly above. All right, I take it as 1.2. All right, so at the third, when at this point, 2, 4, the gradient is going to be y1 minus y2 over x1 minus x2. I'm sure you know this formula. Take this point 7, take away the y, 7, take away 1.2, and here 3, take away 1. Now what you get, here it's 7, take away 1 is a 6, and you minus 0.2 out of it, you get 5.8 over 2. Isn't it very much easier when you divide by a whole number below? You see that why I wanted the x to be a whole number. And when you divide, you can see that the gradient 5.8 divided by 2 is 2.9. Alright, at this point. Now you can see very clearly and distinctively the exponential curve growing at an exponential rate as x increases is always positive, the y. If you look at it, and we can getting more and more confident in drawing the gradients and the tangents, right?